Thank you all so much for joining. We have our host here, Shrikanth. He is our chief data advisor here. Before we even begin into his introduction, I just wanted to take a moment and say thank you all for joining. This webinar is hosted by AI chapter at Sedin Technologies. And thank you so much, AI Innovation team. They have helped us to put it together as well. Now, without a further ado, let me introduce to our host speaker, who is Mr. Shrikanth. He is a chief data advisor at Data Culture. Shrikanth is a visionary in the field of data science, artificial intelligence. He has very extensive experience in data science and artificial intelligence. He has used AI to leverage AI to solve complex business challenges. With his deep expertise in AI technology, Srikanth has been instrumental in driving innovation and helping organizations unlock the true potentials of their data. Today, he'll be sharing us insights on AI copilots and agentic workflows, diving into how AI is helping to transform their business. With that, I'll just hand it over to Srikanth. But a quick note, we'll take all the questions at the end. If there is anything, please drop it in the chat box. Um, Shri- Srikanth, with this, I'll hand it over to you.
Yeah, thanks, Sonia. Hi, everyone. Thanks for joining in. Thanks for taking time out of your busy work to listen to me. Thanks a lot for that. And thanks, Sedin Data Culture, for giving me an opportunity to talk, right? When, yeah, briefly, thanks for the introduction also, Sonia. Maybe I'll give a slightly different version of the of introducing myself, right? So, yeah, so like Sonia said, I have been in data science, or what was called statistical modeling, business mathematical modeling, optimization for over 20 years now, 25 years now. Have been involved with Sedin and data culture for more than a year now, and been great place to be with great people there. So currently, I'm also let me just share my screen as well. Just a second. Okay. Uh, so currently, I'm also a co-founder at another company called Motive, which I started with a friend maybe a couple of like about 4 months ago. Okay, but all of this has been around AI and data science and so on. Uh, uh, Today, I'd like to keep I mean, I had a fairly sort of, I should say, ambitious agenda that I'll go into business use cases, patterns of what AI agents, agentic workflows are, and also a little bit into some technical details, trying to be sort of like a jack of all trades kind of thing, right? But I realized that the time is fairly critical. We don't have too much time, so some of the stuff maybe needs to push for maybe another meeting or another call later, right? Uh, but just want to understand again. I understand that there are people here from different backgrounds, both business as well as technical background. So I'll try to keep my talk somewhere intermediate, focusing on business use cases, but not dive too much into technical details, though I will touch on technical details. So if you have questions, like Sonia said, yeah, please make a note of them. We'll come back to it at the end, right? I'll be happy to answer as many questions as we have. Sonia, I mean, what is the overall time? It's like 4 to 4:45, right? I think.
Yes, we
Yeah.
have 40 more minutes.
Yeah, great. So then what I'll do is I'll try to keep the talk to say 20-25 minutes, and then take as many questions as possible so that it can be interactive. Hope that works. Yeah. Yeah. Let me just move to my deck. So like I said, yeah, I have about 20-25 years experience, been enough about this. Right now, this is a company that we're working with, where we're building AI roadmaps. This I've started with Ashwin, who's also my co-founder at our previous company, Pipe Candy. But this is our second gig together again. Now let's going into details, right? What are AI agents, right? So what you'd see typically is software that acts autonomously to achieve specific objectives, right? Now there are I mean very lot of similarities between say AI agents versus say earlier technologies like say bots or other systems that have been there in the past, right? I mean there are these are all essentially software that get information from the environment as data, sensors, and so on. Analyze the data, make decisions based on the analysis, and then put them into action, right? I mean it could be something as simple as say thermostat kind of thing, right? Like depending on in your air conditioner, where you see temperature going below a certain level that you set as a threshold, automatically the AC turns off. I mean, this acts autonomously, right? So what is new with AI agents? I think what has come out recently in I mean recently, not recently, in the last few years, is the advent of transformer and LLM and these kind of advanced AI technologies, which are very good at making decisions. I mean, much better than say the earlier traditional ML models used to do. So they can analyze complex patterns, learn from complex patterns, and make and arrive at decision making fairly easily, right? So the key for AI agents is an autonomous system that uses LLMs or other forms of AI to actually make the decisions and manage the process flow intelligently, right? So earlier systems, like for example, the thermostat that I mentioned, is a simple rule-based system. You could have something similar to say as part of say something like a typical I mean ERP kind of thing, where you have inventory data coming in. Based on what product it is, you use different forecasting algorithms and you route it, right? But those are all deterministic rule-based systems which are not adaptive in nature. So while here the key is you can use LLMs and others to make decisions. The advantage is these are adaptive to the current situations, right? And so examples, I mean, a lot of these are we have started using them pretty much every day, right? I mean, Chat GPT, IBM Watson Assistant, which is kind of going out and now going to be called Copilot, right? Siri, Alexa, some of them are actually on their way out, right? So you can see the rapid change right now, right? And recommendation systems started out as machine learning algorithms, deep learning algorithms, and now they are becoming more AI driven, where you can where recommendation systems are getting extremely personalized as well, right? Robotic process automation started off as ways to understand how humans do data processing, understand that, and generate robotic process automation. But this is getting evolved with the use of AI into actually AI-driven RPA, where you can not only can it learn from say what human being mimicking what humans do, but understand the patterns and come up with new ways of automating processes themselves, right? Uh, Gaming AI, again, this not only in video games but also it started off when again this started off I mean in the early 2000s, right, with or late 90s with say the chess games kind of thing, where these are I mean deep AI agents algorithms which are very narrowly focused on one specific objective. But now that's becoming now if you look at some of the new uh, games and which are coming out, I mean they actually create entire worlds of their own, and a lot of them are fairly adaptive as well, especially the new ones that are coming in. And autonomous vehicles, which still though not yet a reality, there is a lot of work going on where you have, I mean, you can think of the entire car itself as an agent. Of course, it's made up of much smaller agents, which is what the talk is going to be about, right? So now types of agents. Again, you can classify the agents. If you think through these examples, you would be able to correlate them with, say, what types of agents we have. I mean, there are simple, and these. The reason I'm going through this is one. This kind of classification helps us think about how we can, in business scenarios, right? How can we think of building, instead of building, say, a simple automation or a data flow, or which is what typically we think of when we think of digitization, right? You get data, process the data, build, maybe even build an BI algorithm, AI algorithm, or so on. But essentially, what you would end up with is some kind of score or metrics or reports which you provide to a business user who will then take decisions, right? The advent of AI is makes it so that in a lot of these cases, you can actually, instead of just using these entire data science and AI algorithms to provide insights, you can actually use them to make decisions themselves. Okay. And that's where, like we said earlier, right? AI agents are essentially those that use data science, ML, AI, and other tools to actually make decisions and actually implement those as well. And these are adaptive in nature. Right? Simple reflex agents. I mean, these are directly. So the thermostat that I spoke about earlier is an example of a simple reflex agent. There, it is a simple rule. Here, you can actually have a reflex agent, but which is based on fairly complex and adaptive, say, machine learning algorithms, for example, right? Here, I mean, within, for example, even in a thing, something like automotive vehicle, if you look at a component level, a simple decision of whether I should apply a brake or not, right? This based on who's in front of the car. I mean, is there an obstacle in front of the car? How far is it? And what speed am I going? Just a fairly simple analysis of the environment and a decision to say, should I apply a brake or not? Right? That is a single agent. Now, there is an entire process around, okay, deciding whether to apply the brake to actually applying the brake and the car stopping. But a simple reflex agent can be a part of a larger system of agentic workflows, right? Uh, uh, Now, a model-based reflex agent, they actually maintain an internal model of the environment. So here, for example, things like, say, forecasting systems, algorithmic trading systems, uh, uh, where, I mean, it's not just a simple analysis of the current situation. You need to also understand historical patterns of what has happened, and use that to actually make a decision, right? This is used quite a lot in things like predictive maintenance, where earlier, for example, predictive maintenance was, okay, I will recommend you a time to say when say a car part or a piece of equipment is likely to fail, and when you can schedule maintenance, right? But right now, using AI, you can actually say that if you don't do a maintenance within so and so time, I will actually shut down the car, or shut down the equipment, right? So these kind of prescriptive practices are possible using AI agents, right? Especially in, say, things like, say, medical equipment, and where it is extremely critical to make sure that the equipment is running well. I mean, AI agents can keep track of performance, look at errors, look at any variations from the standard, and even small variations. You can predict, you can understand, and make predictions of, say, what action to take. Okay. Goal-based, utility-based, hierarchical. These are all different kinds of agents. I'll just leave them now to read. Again, So some common. So now, if you look at these as, say, how you look at patterns of agents in terms of how you will build them, uh, how do we see agents in actual practice today, right? What does it what does a user see, right? Uh, so there are some common applications that we've started using pretty much every day, right? Personal assistants. I mean, right now, I think one of the most popular users is, say, using Copilot or ChatGPT for research analysis, or using Perplexity for research and summarization. Okay, there are calendar-based tools which will manage your entire calendar, set up appointments, remind you of appointments. These are all personal assistants that pretty much AI assistants that we've pretty much started using every day, right? Uh, 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 there are tools that record and transcribe conversations. Based on the conversations, you summarize and send out emails. A lot of this is getting automated, and personal assistants are there everywhere, right? Uh, the other big thing is that people who are power users, right, who know how a process works or how certain things need to be done, right? Now they no longer need to depend on, say, something like a IT team or a technology team to build an application that will uh, that they need, right? They can actually. So, I mean, in fact, one of the I had actually put in a few examples here. Okay, but then I came across this tweet and message just today, and I thought this is is a really good example that I can show to illustrate this point, right? So let me just yeah, this one, right? So this is a newsletter that I follow, but here, I mean, if you see, AI as a management tool has become fairly easy, right? So things like, okay, this particular person is talking about how to improve your as a marketing person, who has a team of people who write content for them, how to improve your writing skills, right? So obviously, as any manager would know, you do provide feedback on what your team does, and but now as you provide feedback and best practices and guidance, all of those becomes a learning tool for your GPT, and so eventually you don't need the manager to. You can actually get the first level of feedback directly from the tool itself. Right? So so these and this, you don't really need I mean, you don't really need a high level of understanding of say coding or say application development, etc., to build this kind of thing. It can be done using prompts, right? And this, any manager who knows how to train a team can actually train a GPT, which is essentially uh, uh, what this person says, right? Okay, yeah. These are real. I'll share this with you. These are really good examples of how someone who's really at the top of their game as an expert in a particular field can use uh, chat gpt or llms and other tools to build training, feedback, and improvement material to uh, so this one, right? uh, to actually improve the entire team and improve the performance of the entire team, right? uh, Again, this I thought is a perfect example of what I was trying to say here, right? I mean, in every function, right? I mean, here we are talking about marketing, but you could talk about, say, product development. You could talk about, say, RFP writing or proposal writing or solution design, and so on. And in each of this, as long as you are as long as you are a extremely competent person who knows what you're doing in that functional area, you can use GPT to level up the game of the entire team that you're working with. right? And this is essentially what I meant by saying you can provide superpowers for power users. So one person who would probably delegate, say, to a team can now actually get a lot of this done through agents, and I mean, no, and there is no dependency on a set of other people who need to get the things done, right? Uh, but there are other examples as well. I mean, these are more. Both of these are, in a sense, examples of how AI will make one person more productive. But you can also look at other, say, business solutions, where you can use AI for business. I mean, health tech, especially AI for diagnostics, using, say, understanding scans, understanding I mean, as something as simple as your smartwatch, right? It can track your say everything from your pulse to heartbeat to all the other diagnostics and provide you alerts, right? Whether you're sleeping well, whether walking properly, all kinds of stuff. But to even more advanced examples where you can use vision and other things to, say, diagnose things like cancer and so on as well, right? Predictive maintenance, where I already spoke about, is warehouse optimization. These are things that our team at Sedin in data culture we are working on, right? So predictive maintenance is something that is close to a lot of the work that our clients at Sedin, our partners, are interested in. And looking using AI to actually implement predictive maintenance algorithms, where you're not just predicting when certain event is likely to happen, but actually prescribe what action needs to be taken, right? So the advantage of AI is the ability to move from just prediction and forecasting as an input to decision making, to actually moving from there to actually becoming a prescriptive analytics, where you're saying do this, and even in many cases actually implementing the action itself, right? Warehouse optimization, where again, where do objects need to be stored? What is the best way to store them in order to say reduce costs, etc. I mean, these are optimization techniques, algorithms that have been used fairly in, for a long time. But now, using newer technologies, using newer methods, we have people in the data culture team who have extremely strong expertise in using agentic stuff. So I wouldn't call it, again. There will be a debate about whether it is AI or is it machine learning or optimization and so on. Okay, but yes, the thing is, these are autonomous systems that tell you that predict or prescribe where to store your goods in order to reduce a particular cost, right? So in a sense, this becomes a goal-based agent, which is solving a specific problem for you, right? Fraud detection, again, this is becoming more and more AI. Okay. From the now, as we can see from the earlier case where you had personal assistants, to now, slowly the complexity of the applications keep increasing, and the next step is what is called agentic workflows, where you have multiple agents collaborating and orchestrating an entire workflow, right? But then what does agentic really mean? Right. So like we were discussing in the case of warehouse optimization also, or earlier in the case of a bot, right? uh, Agentic agents, AI, I mean, there is a huge debate depending on whom you talk to, right? Or they'll say, oh, this is not really AI, it is just simple automation. Or it's not AI, we are just using a business rule, or I'm just using simple regression, or I'm using a decision tree to make decisions, and that's not AI. uh, the key here is that we are building autonomous systems that can perceive the environment, look at what's happening, analyze it properly, do a appropriate reasoning, predict what is the best action, and actually take that action, right? And whether we are using a simple business rule to solve it, or I'm using, say, an LLM or a transformer based model to do this decision and workflow, it doesn't really matter. So there are, and this is something that Andrew Ng had put out just a few weeks ago on X, right? There are degrees in which systems can become AI, right? The thing is, we can start building simple agentic workflows and iteratively make them more and more sophisticated, and that's where things like agentic workflows and hierarchical systems actually come in place, right? So here, on the topic of Android, I'd actually like to show a simple show one short video of Andrew talking about agentic workflows itself, right? Maybe let me just bring that up. Oops, need to listen to the ad as well. But, okay, can you hear this here?
We weren't able to hear the audio, Srikanth.
Sorry.
No, we weren't able to hear what Andrew was speaking. The YouTube video, we weren't able to hear.
Uh, okay. Sorry, you guys are not able to hear Prem, or
Yes, Srikanth, we are not able to hear.
okay. Okay, maybe let me just paraphrase what he's trying to say. Right? Okay, this is the screenshot that I had actually put in my deck, right? So essentially, what he's trying to say is, when we started off, say when LLMs came in first, and we started off building AI applications and agents, you would start out with something called, because we assumed LLMs are already trained and they know everything. I mean, they're so magical, right? So you just need to tell them, oh, here, go and do this, and it'll go and get it done, right? So for example, it will be like saying, please type an essay on a particular topic, and this essay needs to be, say, 500 words long, and it needs to be understood by a fifth grader, right? Something like that. And this is what a prompt you would give, and it would and the essay would just and the LLM would just start and build it, right? I mean, this is not how people work. And the same approach, while this approach seems simple from, say, writing out an essay, but even for, say, technical and business use cases, this is how people started thinking of how to use an AI agent. That is, write one monolithic program, or a single prompt which will do everything that the agent needs to do, right? Uh, so like, for example, say, I mean, something like, as simple as, say, things like taking in an insurance claim process, for example, right? Taking in a form, taking in the claims documents. and reviewing the data that's in the document, right? I mean, this seems fairly simple, right? That is, there are documents maybe which are PDFs or other images that come through. It should be possible to try to use OCR and other LLM and other technologies to extract the data out of it, compare the data, and then provide a message out to the customer saying, yeah, all the data is there, or say, oh, the data is not here, so please provide additional information, right? But even as I spoke, I outlined about 4 different steps. When people started doing AI workflows and agents, they're just using one AI LLM or a LLM to do this entire workflow as one single application. Instead, the job is instead what Andrew's saying is to break this down into smaller steps. Each of these steps will cumulatively add to a complete output that you need, right? And that's the example that he has given here. So if I go back to my deck, right? So essentially, what he's saying is, don't start with saying, oh, what your end goal is. Break down your end goal into smaller steps, and once you start with thinking of these achieving these smaller steps, you may be able to actually use smaller scale or smaller size LLMs, small models, or even say traditional ML or transformer kind of models, algorithms, to actually get a lot of these things done, right? So you can uh, so an agentic workflow is so he's thinking saying, think of your task that you want to achieve, or an application that you want to build, as made up of multiple small pieces of tasks that need to be done, and you have one AI manager, AI based agent, who's managing all of this and collaborating between multiple agents, right? And this is where, like we had spoken about earlier, you have different kinds of agents, right? Some which are simple reflex agents, saying, oh, some which will be slightly more complex algorithms, and some are hierarchical. That is, it performs, it behaves and performs exactly like a team working on a particular in a particular functional area, right? So you have a manager or a senior agent who understands the domain, understands what needs to be done, and can trigger off different agents at different points in the system, right? This was fairly common, and this is the base of things such as smart manufacturing and autonomous driving, and this is now getting into business workflows and business application, right? The key patterns from designing an agent are self-reflection, which corresponds to these topic here, is what what do we really need to achieve, and what is required to achieve that. Tool use, again, what kind of smaller activities are needed, and to achieve those activities, are there other smaller say reflex agents or goal based agents that I can use, uh, so to achieve it, right? So for example, right, let's look at say something like fraud detection, right? Or something like a claims approval process in healthcare, right? Now, if I look at uh, a claim that is coming in, you need a claim, somebody who's well versed in the medical terminology, understands the policies, legal information about the policies in place, the uh, company and the individual's policy limits, what is possible and not, and also an understanding of the the health condition for which they have claimed, right? And comparing it with the diagnostic reports and so on. So they need a mix of medical knowledge plus legal knowledge plus business processes, right? Before they can say, yes, this particular claim is approved or not. But that person who needs to do this approval also needs maybe 10 different things to be done, right? So once the claim comes in, what information is contained in the claim? Is it available in a easily referenceable, say, manner, something similar to a spreadsheet or a simple form, right? Then, if this is what is the requirement, then we can build a simple agent, a reflexive agent, which or a goal-based agent, which just extracts the information required from the documents, enters it into a form or a spreadsheet, which is then available, right? Now comparing the information provided with the policy limits, right? The policy would be available in some data store when the customer was onboarded, right? And when the policy was issued. So comparing the current claim versus the policy and past claims and past payouts, and seeing whether it is even valid now, right? So this again doesn't need any domain information, or domain knowledge. It can be done as simple business rules and validation, where you're pulling data from multiple places and doing this comparison. So the point that I'm trying to make is, while there is one person who needs a lot of domain knowledge and business knowledge and business process information to make a decision of whether a claim is to be allowed or not, there are 10, 20 different things that need to be done. And right now, all of those are being done primarily by humans, right? And most of those, which are fairly horizontal tasks, right? Extracting information documents, entering it to forms, pulling information from three different sources and validating it, uh, doing simple analysis to say, uh, what is the percentage reduction for, say, a particular say health claim, right? In case of, say, is dental allowed, or what? So what could be pre-existing conditions? All of these can be done as simple, smaller agents, while you have while you have some while but building a agent which has the medical and the legal knowledge, and AI, building that AI agent takes a lot of skill, a lot of training, and a lot more data on which you can train, because you cannot afford to be uh, I mean, you cannot afford to be wrong, right? So even things like hallucinations that we talk about in AI cannot be taken as an excuse to write in this kind of cases, in a healthcare or financial kind of cases, right? So in these applications, instead of trying to build one application which does, say, something like claims validation and claims approval, you support the claims, the expert, with multiple AI tools which will enable them to do their work faster and improve productivity, right? So that's where we're saying, okay, I mean, agentic workflows work well. So something similar works in, say, e-commerce. I know we are kind of running short of time, so I'll just go with a quick use case. That's something that we released just a few days ago, right? So one of the things that that we had an issue internally with at Motive was, say, as we take interviews, how do we make sure? I mean, technical questions, it's easy, right? But how do we make sure that the people who join us share the right values, have the right attitude, and so on, right? But then this is fairly subjective in nature, and so, how is there a way that we can use AI to actually build something which will standardize our interview process and evaluation of values, right? Uh, Now, again, so here we needed to break it down to smaller chunks, and the way we went about doing this kind of exemplifies some of the uh, data and the points that I was trying to make, right? So one of the things is that is always critical is something called context management and memory challenges from a technical perspective, right? So since most of us use say foundational LLMs, whether it is from OpenAI, Mistral, any of these players, right? Uh, all of these LLMs have token limits, and they also have context limits. Basically, how much information can you pass on to an LLM, which they will then use to kind of uh, uh, I mean, uh, to understand what is required and provide an output, right? But in very often, if you're taking an interview, the interview goes on for say half an hour, 45 minutes, and you transcribe it, it just becomes too long, and the context is just too much for an LLM token, right? The same kind of thing would happen, for example, when you're trying to build an application on, say, a series of prompts, each prompt building on top of the other, which means that the LLM needs to have all of this within its context window to process it. So, which is why you see that even if you use, say, something like ChatGPT or some of these LLMs, and try to build a series of prompts, but after a certain while, you write some 5 6 prompts, then you see that hallucination starts increasing. That's because within, I mean, again, hallucination is a word that I really don't like, because hallucination seems to say there is something wrong with the LLM, but hallucination is not an error. It is actually a feature of the LLM, because it's supposed to be a probabilistic output, right? So how do you control the context window so that the amount of uh, uh, probable scenarios that it needs to process reduces, and it can give you an output which is less hallucinistic or more deterministic, is something where managing the context window and the memory becomes quite important. And that's where, again, going back to the talk that Andrew gave, right? Focusing on agentic workflows, breaking it down into smaller patterns, and building a collaborative system of multiple AI agents, each working in collaboration and orchestrated well. That's essentially what we should be aiming for. And so here, I mean, again, I think I'm kind of running out of time. So let me
Yes,
here
Shrikant, we
now
are
and let
already
me
out
go
of
in for
time.
questions, I think. Yeah.
Yes, we can take in questions. We are already out of time, a question or two.
Yeah. Sorry about this.
Hey, thanks, Shrikant. Actually, it was very useful to understand this, because this is the next big thing that we are talking about in AI. A quick question. One I had put it on chat. The other one is, if I'm trying to understand agents or something that works independently in agentic or the workflows that we bring everything together. Is the understanding right?
Right. Right.
Okay, wonderful. And I also liked what you said, that hallucination are not bugs; they are like features. It will be useful for discussion.
Yeah. So
And
s- s- sorry, Prem, to address your earlier question also, right? Yeah, agents are essentially things that you can, I mean, whether you want to call it a simple rule-based or a machine learning-based, I mean, all of them can be agents, but they're all part of a larger workflow that you can build as a business solution. Yeah.
so the workflow is the agentic that you're talking about. The agentic.
Sorry?
The workflow is defined as agentic, right? Agentic.
Yes. The workflow becomes the agentic workflow. Yeah.
Okay. And there's a question by Abhishek. Maybe you can take that. And after that, I also have a question which I asked, like,
Yeah.
can
Yeah.
AI agents designed to handle emotionally sensitive situations? But we'll go with Abhishek's question then.
Okay. So AI, there is fear in the job market. True. So the thing is, with every advance in technology, I mean, technology is essentially a way of using machines or tools to do something faster or cheaper than what a human used to do. In that sense, yes, there are certain roles that will be cut based on how AI will work. But at the same time, that also provides new opportunities for new skills and new kind of roles to develop, right? For example, I mean, building applications, simple applications using just the way how you write prompts, right? You don't need to go to a coding school or spend a lot of time learning a coding language to build a simple application, right? Now, whether that simple application will scale for business use is a different issue. But as a personal assistant for me, if I need to run a if I am a small company running a campaign to target, say, 500 customers in a particular niche area, I can easily use ChatGPT or Claude to say, "Oh, go and research this industry, build me a list of 500 companies, and get their email IDs from the website." That will take me just 10 minutes to build a list of companies that I need to send an email to, right? So which means that earlier, like companies like which used to build databases for marketing, those are under danger to say, to so to speak, right? But that is only for small companies. But companies that need to send out 50,000 emails a month, for them databases still are required. Yes. So to shortly for Abhishek, for your question, yes, there will be certain jobs and roles that will be cut, but at the same time, we need to understand the reason I was talking about agentic AI is that these agentic AI are going to be your co-workers within, say, 2 years. They'll be your colleagues. You'll be asking questions of them, right? And so which means that there will be new skills, new the roles that will be required. So our job as business folks is to understand where the job market is going, what skills would be required, and train the current generation to work on those skills rather than learning what was useful, say, last year, right? Yes. So
Thanks,
yes.
thanks, Shrikant.
And in fact,
Thank
for the last point, right, how will a non-technical professional cope up? Like I gave the
Yeah,
example, right? I mean, using LLM, you can actually, a non-technical person can actually build technical solutions using just language.
Thank you so much, Shrikant. We'll take one last question because we have been lost out
Sorry.
of time. We'll take one last question and then we can conclude.
Hello.
Uh, Saudamato, are you trying to speak?
Yeah. Yeah.
Yes, please
Thanks
go
for
ahead.
the wonderful session, Shrikanth. I have questions about how I would say that the news in the LinkedIn yesterday, I think, in China has patent generated AI like about 3,000 patents. China is getting. And I would see another one news India has. Uh,
I think this voice is breaking a lot. You're not able to hear clearly. If you can drop it in the
uh,
chat box also, that is fine.
okay. Not able to hear me?
There's a lot of break in the voice.
Okay,
Yes.
okay. Okay, fine.
Yeah, there's this question from Joseph Joshi on
Yes.
yeah, agentic AI to detect types of biases. That's one of the key areas under sort of research or a lot of discussion right now on ethical AI. I mean, not just in terms of human rights and ethics, but also how to use data to and remove these biases. Because if you use automated AI automation to make decisions, then obviously biases are bad. So how to detect and remove biases is an active area. It's not fully solved. Yeah, I would be happy to talk about this separately. Not right now. This is too much to go into right now. But yes, but definitely a very interesting area and very important area.
Great. I think with that question, we will conclude the session because we have run way out of time. But Shrikant, really thank you so much. It was a very wonderful session. For everybody, if you want to hear to the talk again, it should be available on Sedin's YouTube channel. We will soon come back with a next month session as well. So please stay tuned on our social medias and we'll announce our next webinar very soon.
Yeah.
Thank you so much.
Sonia,
Thank you, Shrikanth.
if I may just make a suggestion, that anybody who has questions, if you can just send it, and I'll be happy to take a look at it and answer it separately offline and send it to you
Surely.
back, Sonia, and you can share it with me.
Right. I will be sending a feedback form as well after the webinar. So if you guys have any questions or anything, you can please add there in the other section that would be there on the feedback form, and we
Yeah.
can send it across to Shrikant.
Yeah. Yeah. No, I was just a
Okay,
little too ambitious in my agenda. Sorry about that.
no problem. I
That's
think it
very
was wonderful hearing you. I'm sure everybody's happy. Thank you, guys. We will disconnect.
Thank you, Shrikanth. Thanks, Soumya.
Thanks,
Thanks,
Thank
thanks,
you.
Shrikanth.
everyone.
Thanks,
Thanks,
everyone.
thanks, Sonia. Thanks for arranging this. Yeah, really appreciate it. Thank you.
Of course. Thank you. Bye bye.
Bye.